All right, 4.4, evaluating logarithms and the change of base theorem. All right, so we have common logs and natural logs, which we had very, very briefly talked about in the last couple sections before you took your quiz. But the change of base theorem is kind of the new thing, so I'm just going to put it up here because it's probably been a few days since you did the notes, I'm assuming. So the change of base basically says if we have log base A of x, that we can rewrite in terms of whatever new base. So if it's base A and we say, well, we want it to be base B, we can rewrite this as log base B of x over log base B of A. Typically, though, we're using common logs or natural logs to rewrite this. So the other way we could redo this is we could do the log of x over the log of A, which would be if we used common logs. If we use natural logs, we would have ln of x over the ln of A. And so this is just another way. I don't know why it's putting boxes around everything. Let's turn that off. It's just a different way that we can solve for it. So I actually have a few people in other classes that their calculator is not this version. And even some people like that had this version, but it's a much older version of this. Their calculator does not do the log base thing that I showed y'all when you go to the math and you can choose like what base it is. And so they have to use the change of base theorem every time they're solving a log on their calculator. And so it's actually really easy. It sounds like it's something that's like super crazy, but it's really not. So the first problems, I was like, I am not in the right section because that is not that problem. It's the right page here. There we go. Says, find each value, if applicable, given approximate to 4 decimal places. So basically, these first problems are just type them in your calculator as is. So nice and easy. Number 14, it is the log of 0.01. So all we do on our calculator for that. Yes. So all we do for that on here is we go to the log button, which is the one down here by the 7. And so we just do log 0.01, hit enter, and that comes up to be -2. Turn that off for a second. Okay. 20. I'm going to go ahead and write the next 2 problems, so then once I turn the light thingy back on, I can just finish solving them. 20 is the log of, in parentheses, 296 times 12. And then we're going to look at 22, which is the log of 643 over 287. So basically, just ones where we're multiplying or dividing within the log. So nothing crazy or different about this. It just all goes in the parentheses. So we're going to have log of 296 times 12. And that gives us, it says it wants stuff to 4 decimal places. So this would be 3.5505 because we round up there because that's a 4, the 7 beside it. Do that. So 3.5505. And then this next one, we do log of 643 divided by 287. And since it's just like these 2 things in here, we don't need to like do the little fraction option. We can literally just do the division symbol. Just make sure you close that parentheses so it knows that everything is happening inside. And when I do that, I will get 0.3503. And then, let's see, one more like this one, and then we'll move into one other thing. Or, well, I guess two other things in here. 26 log of 643 minus the log of 287. So when we type this one in, we've got to make sure we close those parentheses on the stuff in the log, because we don't want it to be the log of 643 minus the log of 287. You got to make sure that those things are separate. So we've got log of 643. I'm going to close that parentheses, minus log of 287. What do you notice? Yep, it's the same as the other one. Do you know why?
They're the same numbers? Yeah.
So we have our properties of logs. Log of a quotient is equal to the difference of logs. So they just took this problem and they split it, and that gave us this one. And we could have had a similar thing here with 20 if we had the log of 296 plus the log of 12, and we would have gotten the same answer for that one as well. So this one happens to be the same thing here. So we've got 3503. Like that. Any questions on those ones? Pretty easy, just type it in your calculator, right? If you don't have a calculator, obviously you can't really do these problems, but I think you all have one, so you should be fine. Let's see, the next thing, find each value if applicable, give an approximation to 4 decimal places. So some of these we'll need our calculator, some of them we may be able to just use a property. So again, I'm going to go ahead and write both of them. So 46 is the ln of e to 5.8. And then, let's see, 54, the ln of 0.0077. And then, last one, 60, ln of 33 plus the ln of 568. All right, so this time on our calculator, we will be using the ln button, which is just below the log button. So right down here, just below it, we have ln. So on the first one, I don't necessarily need to put it in my calculator because this fits one of the properties that I have, which is, this is essentially log base e, because that's what ln is, of e raised to the 5.8. Well, when I have that, does anybody remember what that property says that's equal to?
5.81.
So yes, so then log base e of e is what? 1. So that's just going to be 5.8. So, but if you didn't remember the property or whatever, we can type it in. So this would be the ln of e. The E button is right above the ln, so you'll have to hit second ln, and that puts your E in there. And then it wants me to do 5.8. So ln of E to the 5.8 equals 5.8. So like I said, you can either do it by the properties or you can use your calculator. It does not matter. For 54, we'll just do the ln of 0.0077. And I get negative 4.8665. So they still want 4 decimal places on these ones. And then for 60, we have the ln of 33, close that parentheses, plus the ln of 568. And again, that would be the same thing if we did the ln of 33 times 568. So that one gives us 9.8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386. 8386 right, any questions on those? Pretty easy. All right, the last thing in this section is the change of base stuff. So they say use the change of base theorem to find an approximation to 4 decimal places for each logarithm. So the big thing is, I know that you guys can type in log base whatever on your calculator. I need to see that you've written out the change of base theorem like I have it up here. Okay? They do not specify the way that you have to do it. Okay? I would suggest either using the common log or the natural log, because this way doesn't really make your life any easier. It's actually kind of miserable. That's pretty much if they just tell you you have to change it to base whatever. But they don't specify, so choose your favorite. I'll do one with one and one with the other. Let's do 80 first. So log base 2 of 9 equals... And so the way we would do this is we would do log of 9, so I'm doing a common log, over the log of 2. So it's always the big number over the little number as far as when you're doing the change of base theorem. Now at this point you have to type in to your calculator. So we would do, let's see, log of 9 divided by log of 2. Again, make sure you close those parentheses so you can see I have log of 9 divided by log of 2, and that gives me, did they specify again? Yep, 4 decimal places again. So this gives me 3.1699. Now, if you don't believe that the change of base theorem works, we can do it just as math log base like we did the other day. So log base 2 of 9, and when I do that, I get the exact same thing. Okay, so yes, I realize that having your calculator, it's probably faster to just use log base, but if they tell you you have to use a change of base formula, you have to show this intermediate step, but you can always go back and check it using log base. Okay. And then 86, so the last one, unless y'all have questions, log base pi of the square root of 2. So these are some weird numbers. So this time I'm going to use a natural log instead. So I'm going to use ln. So ln of the square root of 2 over the ln of pi. And then we just do the same thing I did on the last one. So ln of, by my square root of 2, close that parentheses, divided by the ln of pi. And I get 0.302, and it rounds to 8. So, any questions? Pretty easy. All right. I don't have too many problems for you. I think you'll be able to get them done even though it's a short class. So 11, 15, 19, 25, 45, 53, 59, and then change of base 81 and 89. So what you may want to do, honestly, is go through and write out all of these first problems where you're just going to be plugging stuff in your calculator, and then just be able to sit there with your calculator and just type them all out. It's probably the fastest way. And then you just have the 2 change of base ones there at the end. So anyways, we have until 10:58, so you've still got almost 20 minutes.
May I go to my locker?
Yes.